Hello learners. So far, we have learned how to calculate the mathematical expectation of both discrete and continuous random variables. Now, we will get introduced with a few properties of mathematical expectation that will help us in various different analysis and calculations in the future. First, let's start with the expectation of functions of a random variable. If x is a random variable with a probability function f of x, and g of x is a function of the random variable x, then the mathematical expectation of g of x, denoted by expectation of g of x, is defined as the summation of g of x times f of x when x is discrete, or the integration of g of x times f of x dx when x is continuous. So if we have some function g of x, which is a function of a random variable, then we can compute the expectation of that function as well. For example, let's take a random variable x with a probability function f of x. If we wanted to find the expected value of x squared, which is a function of x, we can do so using this formula. The expected value of x squared, if x is discrete, would simply be the summation of x squared times f of x for all values of x. And if x is continuous, it would be the integration of x squared times f of x dx over all values of x. The next property we will look at is called the linearity of expectation. If we have two random variables, say x and y, and we have a constant c, consequently, we have e of x and e of y as the expected value of x and the expected value of y. Then, the following properties are true. Firstly, the expected value of the constant c is equals to c. We can easily relate this to the mean of a constant, which is always equals to the constant itself. Then, the expected value of c times x is equals to c times the expected value of x. Then, the expected value of x plus a constant c is simply equals to the expected value of x plus c. Then we have the expected value of x plus y is equals to the expected value of x plus the expected value of y. And lastly, we have the expected value of x minus y is equals to the expected value of x minus the expected value of y. And finally, the last property of expectation that we will be looking into is the multiplicity of expectation. If x and y are two independent random variables and e of x and e of y are their expected values respectively, then the expected value of the product of x and y, which is the expected value of xy, will be equals to the expected value of x times the expected value of y. Note that this is only true for the case where x and y are independent random variables. Now, the purpose of this particular lecture was to get you introduced to the different properties of expectation. These properties of expectations that we just learned will come in handy in future topics and lectures. For example, in the very next lecture, we will learn about the variance and standard deviation of random variables, and you will see quite a few of these properties being used to calculate the variance and standard deviation.